On your do now, I just wanted to remind you that if I look at just the angles with the x values, those two angles together form a straight line, which means that the x values, they add up to equal 180 degrees. And then just as kind of a reminder, 18y plus 5, that angle, and 10x minus 61, those two angles are called vertical angles. And vertical angles will always end up being congruent to each other. So once you figure out what x is, you can plug it back in and then set those equal to each other. Okay, slope review. This line has a positive slope. This line has a negative slope. This line has a 0 slope. And then this special case over here has an undefined slope. Okay, if you remember, parallel lines have the same slope. The slope of line 1, if it's half, the slope of line 2 also has to be half. Okay, perpendicular lines, they don't have the same slope. They have what we call opposite or negative reciprocal slopes. So if the slope of the first line is negative 3 over 4, the slope of the second line would be positive 4 over 3. The fraction changes signs and then the fraction flips. So some negative reciprocal or opposite reciprocal slopes. 3/4, oh, I just did that one. It would be negative 4 over 3. Okay, 2 over 1. We have to put this over 1. That becomes negative 1 over 2. Negative 7 over 8 becomes positive 8 over 7. We make this 1 over 1. So our next slope is negative 1 over 1, which is just negative 1. And then what's the opposite reciprocal slope of 0? If you look at your picture, the opposite reciprocal slope of 0, 0 straight up and down, has to be a line that goes horizontally. So that's an undefined slope. So let's find the equation of a line that goes through the point 0, 4, but is parallel to 2x minus y equals 3. Well, we need the slope. So in order to get the slope, this has to be written in slope-intercept form. We need this in y equals mx plus b, slope-intercept form. So I'm going to put 2x minus y equals 3 over here. I'm going to subtract the 2x to the other side. We get negative y equals negative 2x plus 3. And then we have to divide everything by negative 1. So we get y equals positive 2x minus 3. The whole reason we did this is because we're trying to find our slope. So our slope is 2. So now we know our slope is 2 of that line. Well, parallel lines have the same slope, so we're going to use the slope of 2. We know it goes through the point 0, 4, so that's our x1, y1. So we plug it into our equation. Y minus y1 equals m times x minus x1. So our y1 is 4, our x1 is 0, and our slope we found out to be 2. So we got y minus 4 equals, distribute the 2, we're at 2x minus 0, 2 times 2 is 0. And then we're going to add 4 to both sides. We get y equals 2x plus 4. Thank you. This is called slope intercept form. If I want to put it back into standard form, I subtract my 2x over and I get negative 2x plus y equals 4. But the coefficient in front of x has to be positive, so we're going to have to multiply all of this by negative 1. So in standard form, my answer is going to be 2x minus y equals negative 4. So slope-intercept form, standard form. Okay, how do I find the equation of a line that's perpendicular to a given line and contains the point negative 3, 5? It's perpendicular to 2x plus 3y equals 7. Well, first thing I need to do is take this 2x plus 3y minus 7. I have to get its slope, but in order to get its slope, it has to be in slope-intercept form. So subtract our x over. We get 3y equals 7 minus, let's write it as 2x plus 7. Divide everything by 3. Y equals negative 2/3 x plus 7 over 3. The only reason we did this is because we're trying to find the slope. And our slope in this case is negative 2/3. So my slope is negative 2/3 of that line. However, perpendicular lines have opposite or negative reciprocal slopes. So the slope that I want to use is 3 over 2. What's wrong? So we know our new slope is 3 over 2. Our point is negative 3, 5. So to get the equation of our line, we're going to use the point slope formula. Y minus y1 equals m times x minus x1. My slope is 3 over 2. My y1 is 5 and my x1 is negative 3. So we get y minus 5 equals, distribute in your 3 halves. We're going to get 3 halves x. Negative negative makes a positive, so we're going to have 3 times 3, which is 9 divided by 2. It's going to be 4.5. We'll just leave that right now as 9 over 2. Add 5 to both sides. We get y equals 3 halves x plus, remember this is 4.5 plus 5, which is 9.5, or we can leave this as 19 over 2. This is the equation of a line that's perpendicular to 2x plus 3y equals 7, but goes to the point negative 3, 5. Okay, perpendicular bisector. AB is formed by those 2 points. If line L is the perpendicular bisector of AB, write the equation of line L. Let me sketch a picture. We got line segment A, B. L is a perpendicular bisector. Perpendicular means 90 degrees. Bisector means it has to go through the midpoint. So we need the midpoint of line AB. Line L is going to be 90 degrees to that. So perpendicular bisector looks like this. So I want the equation of line L. First thing I need to know is what point does line L go through? It goes through the midpoint. Since it goes through the midpoint, we've got to find the midpoint. So I like to use a T-chart. You could use a different method from Unit 1, negative 1, 4, 5, negative 2. I'm going from negative 1 to positive 5. I add 6. Well, to get to the midpoint, I just want to add 3. What's negative 1 plus 3? 2. And I'm going from 4 to negative 2, so I'm subtracting 6. To get to the midpoint, I need to subtract 3. 4 minus 3 is 1. So I know my midpoint of line segment AB is at 2, 1. Slope, I can use my slope formula. I take the y values, subtract them, so it's going to be negative 2 minus 4 take the x value, subtract them, that's 5 minus -1. I get -6 over +6, which gets me -1/1. But I need the opposite reciprocal slope of that. So my slope is actually, my slope of the pink line of line L is actually going to be +1. So now all I do is plug my midpoint and my slope into the y minus y1 equals m times x minus x1 formula. That's the point slope form. Slope is 1. I'm going to use my midpoint as my x1, y1, because that's the point that line L goes through. y1 is 1, x1 is 2. And so I got y minus 1 equals 1x minus 2. Add 1 to both sides. We get y equals x minus 1. This is the equation of a line in slope-intercept form that's perpendicular to and also bisects line AB. So let's talk about some special cases. I want the equation of a line that goes through the point 5, 1 if it's parallel to the line y equals 3. So 5, 1 is right here. If I want to graph the equation y equals 3, that means it has a 0 slope. Since it has a 0 slope, that means it's going to be horizontal. It has to go through 3 on the y-axis. So here's y equals 3. Well, I need a line that's parallel to that, so that's also going to have 0 slope. And it has to go through my point 5, 1. The equation of this line is y equals 1 because it goes to the y-axis at 1. Okay, same situation down here. I got y equals 3, 0 slope, of course. It's going to be horizontal. We want the equation of a line that's perpendicular to y equals 3, but goes through the point 5, 1. Well, if it's perpendicular, that means to y equals 3, that means it's going to have undefined slope. So that means it's going to have to be vertical, so it's going to go straight up and down. The equation of this line is x equals 5 because it goes through the x-axis at 5. Okay, now you try this one on your own. Okay, line goes through x equals 4. That means that this line is going to have an undefined slope, so it's going to go straight up and down like this. It needs to go through the point -2, -7. Perpendicular means since the original line had undefined slope, perpendicular means this thing's going to have a 0 slope, so it's going to have to be horizontal. And the equation of this line is y equals -7. See if you can go over these 3 examples and see if you can find